Hi there. So this video is going to address a certain group of problems in section 2-4 from your textbook. We're going to look at solving equations with infinite numbers of solutions. Your book refers to these as identities. So without further ado, let's get started. So example 1, you are going to see that we have an equation here with a variable on both sides, which we have recently talked about in class. Now, on the left side of the equal sign, keeping in mind that we have to simplify each side before we start moving things back and forth across that equal sign. Well, now, on the left side, I've got a 10x, and I have a positive 12. You're going to notice that these are not like terms, so therefore there's really nothing we can do to simplify over here. On the right side, however, you're going to see this 2 that's set just outside this set of parentheses. So what that means, hopefully you automatically start thinking distributive property, because that's exactly what we need to do. Need to distribute that 2 to both the 5x and the 6. So we're going to simplify this side before we get moving with moving things back and forth across the equal sign and trying to get x all by itself. So 2 times 5x is going to give me a 10x. And then 2 times 6 is 12. And of course, you want to remember to take that plus sign and drop that right down in between those. You don't want to lose that operator symbol. Now on the left side, everything's going to remain the same. We just had a 10x plus 12 over here. So I'm just going to drop that down. Now, just like we talked about when we were moving variable terms over from one side of the equal sign to the other, I have a 10x over here and a 10x over here. Well, if I'm supposed to get x all by itself, that means I have to get those two x terms together. So since this one is a positive 10x, I'm going to have to get rid of that by subtracting 10x from both sides of the equal sign. Now, when I do that, we end up with these 10x's over on the left side of the equal sign canceling out, and we're left with just our 12. So let's drop that down. We're not used to that happening. Usually we still have an x term over here, but that's what makes this one a different and unique type of problem. 10x on the left side, or on the right side, pardon me, that drops out with the other 10x. And we're left with a 12 on the right side as well. So you're going to see that our x terms just went away. We don't even have an x in the equation anymore. But what we did find out is we wound up with a true statement. It is a fact that 12 is equal to 12. Whenever you end up with a situation like this where you have a true statement, that means any value of x, any number that's out there that you can think of, whether it's a fraction or a decimal or a negative number or a positive number, any number for x that you would plug into this original equation up top would make this a true statement. That's what this means when your x values or your variable terms drop out and you have a true statement whenever it's all said and done. So what we say that we call this an identity. That's what means no matter what value of x we would choose, it would make the original equation true. We can also say that this is all real solutions. So what that means is, I could try out a value of x equals 3 and take 10 times 3 and get 30 plus 12 is 42. If I put a 3 in over here, I would have 5 times 3 is 15 plus another 6 is 21. And when I multiply that times 2, I would get 42 as well. So I would get 42 on both sides. So that's just an example of no matter what value I would choose for x and plug back into that x position, I would end up with the same amount on both sides of the equal sign. So now, what I need you guys to do is push pause on the video, and I want you to try to work out this particular problem. And then once you come back on, or once you push play again, I will have this worked out for you. So you can check your work against mine, and then I will talk just a little bit more, and we'll wrap this one up. Okay, hopefully you paused that video and have had a couple minutes to work this out. So at this point, if you got stuck somewhere in the process, I'm going to go ahead and walk you through it. I said I was going to have it worked out on the screen, and then I decided maybe it would be good to go through those steps together. So when I distribute over here on the left side of the equal sign, I'm going to have to take 3 times 4b, which gives me a 12b. Write down that minus sign. 3 times 2 is 6. Now I need to bring down that equal sign. Don't forget those symbols. A lot of you guys do that, and that's just going to confuse the issue later on in the problem. So let's make sure we write those down. Then the right side, there's nothing for me to simplify, so I just need to write these down. Now you'll notice that I have a 12b over here on the left side, as well as a 12b over here on the right side. So what I need to do is get those b terms together. Remember, we want to put our variable terms together first. Well, since this is a positive 12b over here, I'm going to subtract 12b from both sides so that I can undo the 12b over on the right. And lo and behold, just like last time, this is a positive 12b minus 12b. It doesn't just undo that on the right side, it's going to get rid of it on the left as well. So over here on the right, my 12b's cancel, and I'm left with just a negative 6. So at this point, with no variables left in the equation, you're going to ask yourself the question, is this a true statement? Is negative 6 actually equal to negative 6? Well, yes, it is. This is a true statement. That means you can call this equation an identity. And you can also say that x, the solution for x, we're going to say it is all real solutions. Technically, we say all real, but all real solutions is what the value of your x is. So x is equal to, this is a weird symbol that means all real numbers. It's an R with a double stick. X can be anything from the real number line, so that's what that means. So hopefully this helped to demystify some of these just a little bit. The next video is going to talk about no solutions. So when you solve an equation and you get no solution instead of all real solutions. So thanks so much for joining me, and hopefully this was helpful. Bye-bye.